Good morning, and welcome to the Wednesday program of the 28th National Space Symposium. My name is Laura Stiles, and I'm honored to be the moderator for today's lineup of fantastic speakers and panels. As a brief introduction, I'm a PhD candidate at the University of Colorado with the Colorado Center for Astrodynamics Research. I'd like to thank the Space Foundation and the New Generation Space Leaders Program for this opportunity and for putting together this fantastic event. Thanks also to Euroconsult for sponsoring this morning's coffee. We start the second full day of the National Space Symposium with a hot topic, hosted payloads. This group of distinguished panelists will help us better understand this important topic. Our moderator is a former commander of the Air Force Space Command and is founder and CEO of L2 Aerospace. Please welcome General Lance Lord.
Well, thank you. It's a great day to be back in Colorado Springs, and certainly here at the Broadmoor on a Wednesday morning. And all that stands between you and all the hospitality events tonight is a few panels and some distinguished speakers today. So we'll get started very quickly here. We're going to talk about hosted payloads today, and it's certainly not a new topic. In fact, when I was the commander of Air Force Space Command, one of my vice commanders suggested that I be the hosted payload. But it's not a new topic, and we've assembled, as you see, a great team here to talk about hosted payloads. And the real issue is we want to explore with them and also with you from a U.S. perspective, a U.S. military as well as commercial, and then also with a little bit of European flavor as well to try to figure out what are the barriers that we need to try to jump over or knock down that will make hosted payloads an integral part of our overall access to space strategy, which I think is a great idea. And we will do that with a series of some short remarks and some slides, and then we hope to have some questions and answers, certainly some questions from the audience. And here I am armed with my iPad, and you will be able to text your question, so don't be bashful. Emerging space leaders have been here all week. They're armed with their iPads and their iPhones and everything, and they're excited about this environment that we're living in. We've got to cut down the cycle times. Maybe hosted payloads are a way to do that. I've got an emerging space leader in my family. He's 4.5 years old. He's got his own iPad. 5 minutes after he had it, he was up and operating on the wireless domain. So I went in the other room and I tried to FaceTime Lucas. You know what? He clicked, he's not available. You know why? He was playing Angry Birds. But that's the world we live in. People want gratification, they want it quicker, they want faster cycle times. Are hosted payloads a way to help break through the cycle time and get things on orbit, get some output from space-related activities, goods and services? So that's what we're going to talk about this morning, and we look forward to it. What does it take to make hosted payloads a critical element in our access to space strategy? First off, we're delighted to have one of the premier space leaders in our business, Lieutenant General Ellen Pawlikowski, the commander of the Space and Missile Systems Center in Los Angeles. And by the way, I think maybe in your package, and I was going to talk about this because it was your homework assignment, she's a recent co-author of a great article about disruptive challenges, new opportunities, and new strategies in space, along with Doug Lavero, Mr. Lavero, who works with her there in Los Angeles, as well as Colonel retired Tom Chrysler. I encourage you to read it because it really speaks to a new strategy. Ellen will be our first speaker, and then I will introduce each one independently after that, and then we'll open the audience for your questions. So Ellen, thank you for being with us. Thanks for being a thought leader and a major shaper and changer in this environment. So please give us your remarks. You may be seated if you like.
All right, thank you. All right, so how many have done your homework assignment and read the article from the SSQ? All right, very good, very good. Good. I'm glad that you all, I didn't even realize that they were going to be providing it as a copy to you, so I was glad to see that. Because really, I don't have enough time today to go into the specifics of what was in that article, but it really captures the essence of where we think we need to be going when it comes to space systems in our architectures. An architecture that provides more resilience, more flexibility, more affordability, and a key to that is frequent access to space using a variety of different ways, and one of those is hosted payloads. The opportunity to get systems and sensors that we need into space without having the large infrastructure that we have today, to include individual satellites with separate command and control systems, with separate data processing systems. Hosted payloads provides an opportunity to streamline a lot of that out of a space system. When I left Space and Missile Systems Center as the vice commander in 2008, we were just getting on contract for what was our first commercial hosted payload called CHIRP. When I got back last summer, in August of 2011, that hosted payload was launched on an SES-2 commercial satellite, and it is the first wide field of view infrared staring sensor that's ever been in space, and our first Air Force commercially hosted payload. It's been a great success so far. We are seeing excellent results from it, proving that the technology does indeed enable us to be able to get very good battle space awareness information and other data, which is really important to our missile warning and defense and our technical intelligence, and also has many civilian environmental applications. That acquisition step we took was the first one we had done, where we looked at where we engaged with the commercial marketplace, and we learned an awful lot about how to put a hosted payload into space, not just from the technical side, but also from the business side. So the real question for us today is, was that a one-off, or was that the first step into the future? Well, when I first arrived at SMC a year ago, I decided that if we were going to make it really that first step into the future, we needed to put a concerted effort towards looking at hosted payloads, towards planning for hosted payloads. So I stood up the hosted payload office at SMC, with its focus primarily to look at what were the potential payloads that could be hosted, because not every payload can be hosted. And then also to look at what were the opportunities. And the focus was not just on the technical side, but also on the business side. Well, that office has been in existence for, it will be almost a year, start in June. When I first got there, it was in June. And so now it's time to take the next step. We've established the office, we've issued the uniform, so to speak, assigned roles and responsibilities. So now it's time to get to work. So I thought what I'd do in the couple minutes I had to just highlight some of the things that the Hosted Payload Office is going to be doing this year. I think first and foremost is that we are about to go out with an IDIQ contract for hosted payload services, which we plan to use to support payload integration, test, launch, and operations. The contract may even be suitable for payload development, but that's part of what we still need to look at. This contract we plan to include owner-operators, as well as satellite manufacturers, vendors and vendors on-ramped when qualified. We will make this contract available to multiple agencies, to include NASA, the NRO, and NOAA, if they choose to use it. We plan to have a fairly long period of performance on the contract, because one of the things that we learned out of the CHIRP experience is that we do need a mature payload when we start this process. So we're looking at starting in this year, probably 3 years of concentration on the payloads before we actually are able to look at actually launching anything. That's a key lesson learned, is that you have to have a mature payload. So beyond the outlook for that, we're anxious to be able to get the right relationships established. We know how important that is as we go forward. What we expect this contract to do is to do some systems engineering studies and analysis, but also engineering product development. And a couple of the product development things that we have the hosted payload working on is, first of all, is a hosted payload standard interface specification. We're doing this in collaboration with the commercial spacecraft industry to understand, to be able to provide a standard interface for our payload developers to facilitate the integration and to reduce the time it takes to go from a payload development to a payload on orbit. Another key thing that we're doing that we learned out of the our work with CHIRP is to establish a hosted payload interface unit. When we talk about national security payloads, we deal often with, we need encryption of the payload downlink as well as certain information assurance requirements. And if we're going to do that, we have to provide that. It's not a standard thing for many of our commercial vendors. So that will be a standard that we will use, an interface unit that we will use across all of our payloads. But we're not just on the infrastructure side of hosted payloads. We also have some pretty wide activity associated with our individual directorates at looking at specific payloads for hosting. For example, our infrared systems directorate is in the planning stages for what we're calling CHIRP Plus, the next generation of a wide field of view overhead persistent starer sensor. That is looking very promising. We're doing that in conjunction with a Department of Defense study called JOIST, which is a Joint Overhead Persistent IR Integrated Space Trade Study. And out of that, we're seeing pretty much confirmation that wide field of view technology for hosted or on a free flyer is definitely an area that we see our OPIR architecture leading in the future. So we're still in the early stages of that, and as with almost everything else right now, the budgets are still preliminary, but we're very excited about what we've seen from CHIRP, and we really are very optimistic that we will be in the CHIRP-style payload business in the future. In the area of weather, our hosted payload office is working with our weather directorate and Orbital Sciences Corporation and to look at a suite of space and terrestrial weather sensors to determine whether they're suitable for hosting on Iridium NEXT constellation, which is a low Earth orbit communication satellite constellation that's due. There's some swap available on those, and that maybe we're seeing that as a potential target of opportunity to be a key part of our space architecture in the future. So hosted payloads for space, for weather, both terrestrial and space weather, is a strong area of concentration for us, not just potentially on that particular host, but potentially on other hosts as well. In fact, we have an activity ongoing, some international activities on hosting payloads, weather payloads. In the MIL-SATCOM area, we have already been issued some broad area announcements looking at tactical EHF payload, and once again, that is looking very promising as part of our future architecture for satellite communication. In the wideband communication area, as we look to try to provide the best product for our warfighters when it comes to that variety of commercial communication satellites that we use today, as well as military satellites, the opportunity to host one or the other on a military KA, on a commercial satellite to help with that transition, to provide more flexibility, is another area that we're actively looking at. Then finally, in the area of space situational awareness, we had an industry day in February, what I like to call our neighborhood watch in space opportunities, where we put space situational awareness sensors on as many satellites as we possibly can to provide that much needed space situational awareness in space. So I think my message today is that we see hosted payloads as a key part of our future architectures, and we are this year, as you'll see in 2012, we're moving out to actually have some real directed activities with this, to everything from making sure that we have the right infrastructure elements in place, like the standard interface unit, to exploring the real specifics of individual payloads. And so I look forward to your questions as we go forward.
Thank you, Ellen. Very good. The audience is excited. I'm starting to get questions, that's for sure. For the emerging space leaders, I cannot accept resumes over this system, so there's a lot of people excited about this topic, so we look forward to that. Let's quickly jump over the ocean here and open up with a little European Space Agency flavor with Mr. Philip Sivak of the European Space Agency, 20 years of experience in space projects and firsthand knowledge. Philippe, what do you have to say about hosted payloads?
First, I want to thank you for inviting me here to this panel. and I'm going to present 3 cases, 3 missions that we're currently developing in ESA, mostly in the telecoms area. So just first a reminder, European Space Agency is 19 member states. I'm sure you all knew that. And in the few minutes I have, it's very difficult to mention all the space agencies and all the industries of each country. So I'll try, but if you're out there and I don't mention your name or of your space agency or your company, just ask a nice and easy question, and then I'll make sure I give you full credit for your contribution. So on to the first mission, AlphaSat. It would be nice to show on the screen. So you see the size of the spacecraft. It's a very big spacecraft. AlphaSat is first and foremost a private mission for Inmarsat, where Astrium is the prime, and the purpose is to fly L-band geomobile telecommunications mission. But it's also a public element to it because it's the first opportunity to fly the new AlphaBus platform. AlphaBus is a joint development between Astrium and Thales Alenia Space, and under contract to ESA and to the French Space Agency. You see, I'm dropping names here, so I hope I get through all of them by the end of this talk. So AlphaBus, this is a first opportunity to validate this bus in orbit. But since it's a big platform, big satellite, we have room, and we have complemented that mission with 4 hosted payloads. And the idea is to embark new technologies. So they're demonstration payloads, clearly to validate key technologies. So you can imagine it's already a complex setup with industry, operator, agencies, and we bring in 4 extra partners to this mission. So we've had to cope with that, but we've managed that successfully. The main issue we've had to deal with is the readiness of the hosted payloads. Because they were a demonstration, they were all in development when we took them on board, and as you can imagine, none of them were on time. We're actually just getting the last one at the end of this month, so we're nearly there, and we're on track for launch first quarter 2013. So that's AlphaSat in a nutshell. I just want to highlight that the last payload that we're going to get is a very important laser communications terminal. It's the first time we're going to do, with this technology, GEO to LEO telecommunications with optics. And it's a very important step to the second and third mission I'm going to talk about. So the next 2 examples come from the European data relay system that we're embarking on. It's I'm not going to detail the system here, but it's in a nutshell, in partnership with industry, trying to establish LEO to ground high data rate communications via GEO, using optical links primarily. So the first, so Akos of Astrium Services here is one of the next speakers, and he will be able to detail this architecture. From my side, I'll concentrate on the hosted payload aspects, and the first element of this EDRS architecture is just a hosted payload. It's called EDRS-A, and it will be one of these laser terminals flying on a purely commercial spacecraft, a Eutelsat 9B. Launch is planned for 2014, and so far, as I know, the accommodation is not such a big issue, but we're changing from the demonstration arena to the operational arena here. We have to have a full service for 15 years on board a telecom spacecraft to ensure a critical part of the EDRS mission. So this is a very different mindset. You're not working on the margins of the power budget. You're not just looking at limiting failure propagation and interfaces. You have to ensure a full operational service of a hosted payload on board another mission. So it's a different attitude. I think we will go to the next slide. The second component of EDRS is EDRS-C. So obviously B was too expensive and was canned. This is a completely different setup again. We have a small spacecraft on which will fly one of these laser terminals and a K-band downlink. And because it's a modest payload, we have enough space on our platform to host, to be a host, and to offer hosted payload capability. So basically, you can see on the small diagram, one half of the spacecraft is dedicated to hosted payloads, while the other is for the laser terminal and the EDRS main mission. So now there's a new challenge. We have a spacecraft which is more or less 50-50 main mission and or EDRS mission and hosted payloads. So both are competing for resources on the platform, and we have to have a balanced attention to both. And this has impacts on your development, impacts on your testing, impacts on the operations that all need to be worked on with both payloads in mind. So the launch of this is 2015. So you see we have a sequence 2013 AlphaSat, EDRS-A 2014, and EDRS-C 2015. So we have a lot of work ahead with these two last missions. And I think as a conclusion, hosted payload is a lot of work. We have to get away from the traditional thinking of monolithic missions with just one project manager, one spacecraft, one launch. That's our comfort zone, I think, for most people who've been in the space business. And now we have to change our approach from contracts all the way to testing. And this is indeed a lot of work. And lastly, I think agencies can definitely play a role in this by initiating these kinds of precursor missions that allow to deploy systems at minimal costs. Thank you for your attention. Look forward to your questions.
Thanks, Philippe. Thank you very much. Thank you. I want to gently remind the remaining panelists that we're on the clock. We're in the countdown clock here, and we will launch in 38 minutes and 34 seconds. So if you get my message. Next, the individual on the panel with probably the most stimulating and exciting title is Dr. James Reuter, Acting Director for Game-Changing Technologies and Cross-Cutting Capability Demonstrations at NASA. Now, that sounds like an exciting title, and somebody that we would like to bring forward here to talk a little bit from the civil space side, on NASA side, about hosted payloads. So, Dr. Reuter.
Thank you. Let's go ahead to the next slide.
Next slide, please.
Next slide. So the Office of Chief Technologist within NASA is new in 2011. We've been up and running for about 2 years now. And for the first year, we were primarily in formulation, trying to get the office up and running. And it has several functions. It has an up and out function to the NASA administrator and to the NASA stakeholders. It also has integration across all the technology areas within the mission directorates within NASA. In other words, space technologies are not just done within the Office of Chief Technologist. They're actually executed across the whole agency, including the Science Mission Directorate and the Human Exploration Mission Directorate. And so there's a coordinating function that the Office of Chief Technology does over all of the technology areas. It also leads the transfer of technologies from NASA and from the government side over into the private side, and that includes technologies that are derived from any of the areas within NASA. It advocates for the technology programs at all levels. Part of my job here today is to go and do that advocacy. I'm representing Mason Peck, who is the current chief technologist. He couldn't be here today, and so I'm trying to fill in for his big shoes and trying to advocate for the need for technology development within the agency and within government as a whole. It also demonstrates and communicates the social impact and needs for technology development. It isn't simply technology for government's sake. It's definitely space technology development for the entire aerospace enterprise and how it impacts everyone's lives on a daily basis. And then finally, the piece that a lot of people are very interested in, of course, is the technology programs that are under the purview of the Office of Chief Technologist. In 2011, we had a budget of about $350 million. In 2012, we had a budget of $575 million. And indeed, by the middle of 2011, we had kicked off several activities to try to get going with technology demonstration capabilities. And when we say there's a portfolio of technology programs that spans the entire technology spectrum, everything from fellowships and very low TRL, innovative concepts development, all the way up through technology demonstration missions where in fact we do need to get a ride in order to demonstrate a technology in a relevant environment. And usually that means taking it all the way to space. One of the programs we do have is the Flight Opportunities Program that in fact does suborbital flights, and we have an IDIQ contract for 7 vendors that supply flights on suborbital missions. And the reason that we purchase those flights through that IDIQ contract is to, in fact, test technologies where suborbital microgravity and suborbital space environment is enough to demonstrate the technology. And so it's really a model for saying, hey, you actually can do this IDIQ approach to things, and you could get vendors on board. In this case, we've got 7 of them already on board, and we are manifesting flights as we speak to get small technology payloads tested in a suborbital environment. At the larger end of the spectrum, we do technology demonstration missions. Technology demonstration missions are where we cross the valley of death for technology development, and we actually do perform that demonstration in space. When we're performing those missions, they're tens of millions, if not hundreds of millions of dollars in order to perform a single mission. And all we're talking about is doing technology demonstration. Now, many times we will try to gang that together with other mission objectives, but the primary objective from Office of Chief Technology standpoint is the technology demonstration. Having said that, there's many things that come to play. We always have affordability challenges when we talk about technology demonstration. And affordability challenges means that we're going to try to run at a higher risk posture than you normally would in a primary science mission or a primary human exploration mission. And so it is okay for a technology demonstration mission to fail. In other words, to not succeed either because of programmatic reasons or because of technical reasons during the launch. It's okay for us not to have every one of these turn out to be a success. We expect that some of that will occur. Obviously, our risk tolerance as the dollars go up becomes more important, and we look more carefully at how much risk we're willing to take. But we're always looking at this from the standpoint of an informed risk posture where we understand the risks that we're taking on, and we therefore decide how to trade those costs of risk off with the importance or the likelihood of that risk. But there is one point that is very important in this in technology demonstration missions, that what we need to do is we need to make sure that there's a customer at the end of the road that is actually going to take this mission and go use it on a primary mission, whether that's a NASA mission, other government agency mission, or it's a commercial entity that wants to go and use that for the space enterprise. We're okay with any of those. The most important point is that we have that person at the end of the pipeline that's actually going to take over and fly that technology at the end of the day. If we don't have that, if we don't have that infusion customer, then there's no point in us doing it, because we're not going to put a technology that we spend hundreds of millions of dollars to demonstrate in space and then go put it on the shelf. It's not an acceptable position from our standpoint. So when we talk about the posture that OCT has, it's very important to understand that we're always balancing risk versus affordability. And when we talk about affordability, we immediately jump to trying to find the cheapest ride to space that we can in order to demonstrate that technology in an environment. And of course, hosted payloads is a very important space within the affordability trades that we do. And wherever we can, we end up having, if the cost-benefit trade goes towards a hosted payload, we are going to go and do that. Because we are technology as opposed to science or human exploration, we're not afraid of the consequences of having to hitch a ride and stick out our thumb and just anybody that's willing to come along and take us to space, we're going to be okay with. And we're also willing to take on the challenges of getting through any regulatory hurdles and working with the hosted payload, the provider, and making sure that they could accommodate us. We're very concerned about manifesting ourselves onto these vehicles and making sure that we get a ride, because we know that launch manifests change all the time. Well, we could be a little more patient than, let's say, a science mission or a human exploration mission. All of our missions are typically Category 3 Class D, which means that we are willing to take those higher risks. And it's going to be, within the Office of Chief Technologist, a primary approach to how we get to space. We're not going to be buying primary launch services in only but a few cases. Those will be the exception and not the rule. The rule will be hosted payloads, secondaries, ride shares, and other opportunities that we could find. Next slide. So we know that there are some limitations in the U.S. space transportation policy, and of course the Office of Chief Technologist is advocating very hard for greater flexibility within the U.S. space transportation policy. NASA contracting and procurement is also, of course, a big hurdle, and we're working very hard with the procurement offices and at headquarters as well as the NASA centers to make this more amenable. I do think that we are on the pathway to success from a procurement standpoint. We do have some successes that we've recently done. The example to the right, where we're doing laser communications relay demo, it is a hosted payload on Loral, and we do have a signed contract with them to actually go and perform that mission at this point. Another big point that we need to talk about is hosted payload costs. You'll see a lot of people are saying, hey, we have hosted payload opportunity on our missions, whether that is geocom birds or many other places that have opened up. That's fantastic. But of course, if it turns out that these costs to do the hosted payloads aren't much different from a primary launch service provider, then it doesn't do anything for the Office of Chief Technologist.
Sir, could I interrupt here for a minute? That's one of the questions that has come up 3 times already. Can I ask you to hold that, and
sure.
We'll shift gears here, and our
yep,
next speaker,
I'm done.
And okay. Let's take that slide off, because this is one that we want to question all of our panelists on. And next, in 5 minutes or less, I know that General Arnold's is going to do this for me as the Vice President of Space Strategy for Raytheon and the Space and Airborne Systems business, previous commander of Space and Missile Systems Center. I'd like Brian to give us his perspective. Brian.
Thank you. I've eliminated the start joke and the end joke to keep it within the time limit there. Thank you, General Lord, for inviting me. Good to see General Polakowski. I'd like to thank the National Space Foundation and the Hosted Payload Alliance for sponsoring this important topic to talk about the innovative ways we can use hosted payloads. As General Lord said, we've been talking about this subject since he was the commander, and that's a long, long, long time ago. But the idea here is, so how do we, the subject of the sentence is, how do we make this a reality? We've been talking about it at these panels and others for a long time. We have some examples, but how do we make it a reality in our day-to-day business? I've got the 3 main points. General Lord and I were both SOS instructors, and so you tell them what you're going to tell them what you told them. So the first factor is, what are the factors? And I believe cost is the overriding factor. Simply put, as the defense budget goes south and the cost of space operations goes north, there will be a tipping point that will drive us to more economical solutions. And clearly, either A, you're going to do without that mission, or you can try to satisfy it in a cheaper way. And I believe that hosted payloads offer us an opportunity. While I don't say that they will take care of every mission that we have out there, they will give us an opportunity to perhaps satisfy that. So I think cost is really one of the bigger points to focus on here. It gives us reduced cost of operation, cheaper, faster cycle times, reduces the cost, the burden of the pay for the launch, et cetera. In terms of availability, just look at the launch manifest today. It's dominated by the commercial market. It's time for the U.S. government to take advantage of that and move on and start hosting payloads, taking advantage of the commercial launches. As far as mission supportability, we've all heard that space is congested and competed. And certainly, if you look what a hosted payload can do, it can be disaggregated. You can launch these things in rapid succession. So it offers you the resiliency for your architecture as well as for that individual capability. As for technologies insertions, as our gentleman from NASA has pointed out, it gives you the rapid ability to insert new technologies in a quicker fashion. And then finally, I would offer to you the influences of the commercialization of space, clearly driven by the rise in second, third world nations' economies, the worldwide demand for faster and more broad flow of information drives us to that point. So I would say let's take advantage of that commercialization of space. So what are the challenges? The key challenge, I believe, is the fear, habit, inertia. Now, I think General Polakowski would agree with me that we've all come through some tumultuous times in space acquisition. And clearly, the processes that we have in place are tried and true and battle tested. And we as industry leaders and government leaders are reluctant to change course now that we are back on track. Let's keep it that way. So we tend to be a little bit risk adverse. We don't like surprises. I was the PEO for space, and I never did like surprises. But I would tell you, I think we can take advantage of some of the things that are coming along in a much faster way. And I would just say that we've got to move on and look for better solutions to do that. Now, as far as government acquisition practices and policies, they're dynamically built around the mission itself. So how do we insert the payload, the hosted payload, into the process here? First of all, I would offer that not all space bus providers build the payloads. I think we need to look at new innovative contract arrangements, but most importantly, we need to break the paradigm of how do we become a program of record. If you look at the track record for hosted payloads of late, they're out of cycle with the PPPS process. So the subject there is we need to insert that early in the process so that it becomes a funded program, and then it has at least the potential to survive, because you can't enter in the middle of an execution year and hope to achieve any kind of funding at all. It just doesn't happen, particularly in this kind of a funded environment. And then lastly, we need to look at the development and production timelines of the commercial market, typically 24 to 36 months. So how do we insert ourselves there? How do we meet the space, weight, and power considerations for the hosted payload? And then the government needs to work faster to get the funded payload in there in the discussions early on. So what are the keys to success to making this, the hosted payloads a reality here? First of all, I believe that we need to include it in your analysis of alternatives to see how you can satisfy it. Look at satisfying it at the 75 to 80% solution versus the 100% solution, because the delta difference there to drive to the 100% often costs us hundreds of millions of dollars. We ought to be satisfied at the 75% solution, at least to meet the needs of the schedule. Secondly, we need to include hosted payloads, I would offer, earlier in the discussion with the primes and the government to ensure that funding and the lead times to meet the ride. And finally, I applaud General Polakowski for standing up a hosted payload office. We need a single point of contact within the government we can go to. They know how to do the contract arrangements for hosted payload. And so with that, I'll close my remarks and look forward.
Thank you, Brian. Very well done. Next, let's ask Akos Hedgie from the European Data Relay Satellites System Services at Astrium to give us his perspective. Akos?
Yeah, so thanks a lot for having me on this panel. We have got a movie here, but so apparently it got mixed up a little bit, but that doesn't matter. I would like to share with you our insights, some additional insights on the Space Data Highway, EDRS, that Astrium Services GmbH is implementing together with our partner ESA. And we would also like to give you our view on how the US government can profit from this scheme or similar schemes in the domain of hosted payloads. So the Space Data Highway is a data relay system that is going to be an operational system starting in 2014, as Philip has mentioned. And we are going to provide the capability to UAVs and also to low Earth, Earth observation satellites in low Earth orbit to send their data near real time back to the user through geostationary systems, and also to task UAVs and Earth observation satellites in near real time. Now, this Space Data Highway is a public-private partnership between our partner ESA and Astrium GmbH, and it is a public-partnership in a way where ESA, the space agency, and foremost one of the key members of ESA, DLR, is funding a large part of the space infrastructure. And Astrium GmbH is funding the other part of the infrastructure and has taken a commitment to operate the system at least until 2030. Now, in this public-private partnership, ESA, or to be more precise, European governments are going to be the anchor customer, and the Space Data Highway is going to provide an operational data relay system to a constellation of European Earth observation satellites called GMES Sentinel. And as Philip has mentioned, the first satellite, the first geostationary satellite providing that service is going to be a hosted payload on a commercial satellite. Now, the good news is that a lot of the capacity of the system is available to trusted allies or the US government to use it for services to get near real-time access to UAVs or Earth observation satellites. And there are two key elements in this scheme that are, I believe, particularly interesting. One of them is a new technology that is being injected here, and this technology is a laser technology developed in Germany with the support of the German Space Agency. And it's an operational laser terminal that provides a 1.8 gigabit per second link from the UAV to the GEO or from the Earth observation satellite to the GEO. And that is a capability that is now there to be used. So it's prime time for this terminal to be used. And of course, the other element that is of interest is that this is a program that has been fully funded, that is being implemented as a public-private partnership. So the US government and trusted allies can use it as a service and pay for it by the pound. So what are the specific benefits that US government and other governments can draw from a scheme like the data highway or from other schemes that my fellow panel members have outlined? Well, the benefits are manifold. First of all, the technologies are there. They are state-of-the-art technologies, and they are ready to be used already. They are operational. In the case of the Space Data Highway, they can be used to provide a service to UAVs. It's a very, very high throughput capability without the risk of development, because the development has been already done by DLR and industry. And moreover, there is even an opportunity to implement a cooperation between the US and Europe to go beyond the two geostationary satellites that are being implemented in the context of EDRS, Space Data Highway, and to start to think about an additional node or two additional space nodes that we are already in fact structuring, and to cooperate on this one and to shape it in a way that best fits the US government and trusted allied needs. So I believe these type of schemes have many benefits for the government and trusted allies, so I think they do deserve a closer look.
Thank you very much. I apologize to the audiovisual folks. I called it audible at the line of scrimmage. They caught it, and I flip-flopped the order of our last two speakers. I apologize. But Dave Anhalt, who's been helping us from Loral, thanks, Dave, for being ahead of me anyway. And next we'll hear from Dave's boss. I wanted Dave to be known that his boss noticed that you did that really well, so I want to make sure that would. But Arnie Freeman is the Senior Vice President of Marketing and Sales at the Space System Loral. And we've heard several perspectives. Now let's get a good commercial look at hosted payloads. And Arnie, thank you for being with us. And please tell us what you think.
Good morning, everyone, and thank you, General, for hosting the panel. You know, many people are amazed to find out that there are 300 GEO commercial satellites circling the globe, and well over 100 LEO satellites commercial going around the globe, and all done on fixed price contracts, all extremely reliable. The commercial industry is robust, it is continuous, and it is growing with the bandwidth demands of the world. And on this chart, you're going to see the major manufacturers. I'm showing the GEOs. You're going to see 75 satellites. That's not an unusual number. And all these satellites are opportunities for hosted payloads, and all these satellites will be launched in 3 years. Now, as we speak, more satellites are getting awarded, and we have satellites at the launch base. So now, let me talk about hosted payloads in general. The governments around the world use lease capacity on commercial satellites all the time, but that's not what I'm here to talk about. I'm here to talk about cases when the government actually hosts payloads or buys dedicated commercial satellites for their needs. And that's done for decades by the US, by Australia, by the Europeans, by Japan, by Mexico, and many other nations. It's something that's just been done and we've been involved with, as other people in the industry have been involved with. These are not for all demonstration missions. These are for operational missions. Yes, these are integrated into the system architecture, and they work, and they're critically dependent on these around the world and in the US. They're highly reliable. You know, there's nothing more important than the warfighter and the support to them, but the commercial is driven to the same high standards for different reasons. I occasionally get asked, do commercial manufacturers like this business, you know, of working for the governments? It's sort of, to me, it's a question that I don't understand because we've been doing it for so long. The industry, you know, likes it, depends on it, it's valuable to it, it creates jobs, and we do it all the time. And I'm not just talking about the manufacturers, I'm talking about the operators, I'm talking about the payload providers and others involved in the sequence. So we're not here to say, and I think everybody knows, commercial satellites aren't for every mission. Hosted payloads aren't for every mission. Especially exquisite and others. But there are some opportunities for them where they make very economic sense, whether it's OPIR, space stational awareness, WAS, weather, and many other things. And we appreciate, in some solicitations, we appreciate the efforts in the USG and having a hosted payload office. We appreciate the OCT, NASA OCT office for adding hosted payloads as a possible solution in their solicitations. It wasn't just dedicated, you could come in with hosted payload solutions. We appreciate that as being in the alternative space, and that's been very effective. What I've done in the charts that I've that are flashing around. I just picked a few examples of existing satellites, so you can just take a look at what's been up. These are just a subset of all of them. They're different manufacturers, they're different operators, they're different payload providers, they're different government agencies, and they all are working and providing services, needed capability on orbit. So thank you very much, and I appreciate being part of the dialogue.
Thank you, Ernie. I want to congratulate all 6 of our panelists here for coming in under the time budget, and we've got about 10 minutes left for a little Q&A. Lots of questions have come in. One thing I'd like to, though, is really for us to focus on during the question and answer period is really to take a look at. We've got the opportunities, I think we've got the technology, we've got the framework set. In fact, the Hosted Payload Alliance has doubled in the last year since we talked about this at the Broadmoor a year ago, last spring, and we've got a lot of interest. Now, really, the question becomes, how do we shift gears and really move into that? We've got some recent success with CHIRP and other commercial and foreign kind of opportunities. So how do we really go from an opportunity change to a culture change? So the first question I'd ask the panel is, oftentimes, and certainly in the government side, and Ellen, if you wouldn't mind taking this on initially, because it kind of underlies a lot of the questions we've got right here, is how do we really change the culture when so many times that maybe the opportunity for a hosted payload and certainly the output of that payload may fly in the face of an existing program and compete with something that a big SPO might want to do? And how do we make sure that we can work that problem and really get at the culture change that may be a barrier there? Could you offer your comments, and then I'd ask the rest of the panel to chime in as they like, okay?
Well, I think that the concern you point out is a very real one, and one that we've spent quite a bit of time trying to tackle over the last year. And I think from a national security space perspective, it takes a across-the-board look. When I talk about hosted payloads, I often talk in the same context with revisions in our architectures. So it starts with the requirements community and a discussion with the warfighter about what's really needed and then what the context is, as opposed to starting, oftentimes, even though we say we start with a clean sheet and requirement side, we oftentimes start with a particular system in mind that we're going to go out and buy with a large elaborate acquisition system program. So it's got to start right from the beginning. And that's some of the work that we did with Air Force Space Command in building some architectures, which, by the way, I'll talk about at my luncheon speech tomorrow, where we have tried to set the stage with the warfighter with what that these requirements can be met without having a large monolithic system. But the other piece to this is also in our acquisition community, with an understanding and an appreciation of different business strategies and business approaches. And that is one of the reasons why I stood up the Hosted Payload Office, because just with whether you're in industry or whether you're in the government, when you're in charge of a large program and you've got the responsibility, you're being held accountable for the baseline for that program, whether it's the cost, bringing it in on cost and on schedule with the requirements. And so that's what you're focused on. And when somebody comes in and says, hey, I think I can do this for you with, this other approach, well, wait a minute, my focus is on this program that I'm asked to do. So by establishing the Hosted Payload Office, my objective was to introduce that different culture and with a different skill set in terms of understanding the business relationships that are different when you're approaching a commercial service provider as opposed to a national defense contractor. So it takes across the whole spectrum, and it just takes time, and you have to carve out those little places where you can nurture, like the Hosted Payload Office, nurture those ideas and concepts that are so important.
Okay. Brian?
Just to offer a perspective now, being in industry as well as formerly in the government, and in General Polakowski's shoes. If you look at the nature of the large binary systems, we typically try to put as much as we possibly can on that. And so the culture is driven to satisfy the military requirements. As you used to say, we buy military equipment because of the efficiencies gained in the prosecution of war, right? But if we take a look at the history, the track record for those large complex systems, it's crazy to try to meet the 100% solution. So we've got to come to the realization, I believe, and change that culture that I can meet that at a 75 or 80% solution much quicker than trying to drive it to that last 10 or 15% that absolutely kills us. So if you can look at it, can you disaggregate the solution of the requirements over several payloads and perhaps answer those much quicker? And I believe that we would begin to see and accept those, and the culture would begin to change.
Yeah, I'll just say one thing quickly. You know, I look at our backlog, which is in the mid-20s, and I think we have 2 satellites that are the same. You know, our customers put something up and they evolve, and that's a different type of thinking versus trying to get it all perfect the first time. So getting something up, working, getting the next generation up another couple years later, and that type of philosophy. It's just something to consider as an alternative for some missions.
Go ahead.
Yeah, from the European perspective, one key success factor to shape this mindset was that ESA was willing to develop a trusted relationship between the agency and industry, and first to give us to clearly outline what was the budgetary limit within which we could implement the capability that was needed, and also the willingness to spend the time to develop that relationship. And in turn, industry was then able to tailor the contract vehicle to the exact needs and to deliver an assured service. So I think this is the key to develop a trusted relationship. It does take time, but once it is there, then there are big savings to be made.
Okay, very good. Dr. Reuter?
You know, most of NASA's missions, they're in control of their own destiny in terms of they being a primary mission, a dedicated mission to go do a certain activity. And in fact, many of the project managers don't want anything else on those missions. They don't want anything on the launch vehicle except for their particular project or payload. The Office of Chief Technologist is quite different from that in the sense that we recognize that we're doing technology development, which means that we're going to be listening to whoever is the primary and saying, okay, they're in charge of their destiny, and we're just on for the ride. And so we take it on as our own challenge to say, how do we manage against that situation? And so, you know, in terms of how we do reviews and budgets, we actually look at, you know, the usual things that everybody is reviewed against: cost and schedule and technical and looking at risk. I mean, we look at those 4 things, but we also add, whenever we're in a technology demonstration mission, what is your ride? Who is your ride? Because that will change, and certainly the date will change, and it's not in your control. And we recognize that, and we're okay with that. So we actually want to let the primary actually control that situation and recognize that we are a secondary.
Philippe, any?
Yeah, I think the real catalyst in all this is cost. When you have a very limited budget, you have to work and find solutions, and hosted payloads come naturally in the picture, and I think that's what we've done in the past few years at ESA, and allowed to deploy a system like a EDRS, and also key technologies on an AlphaSat. So maybe you should try reducing the budget drastically and see how that changes the mentalities of people. And then, of course, afterwards, you increase it a lot.
Thank you very much. We're almost to the end of our time here, and I want to take just a minute to sum up a couple things. There's several questions that I want to claim limited executive privilege here and ask our team here to take all these questions that have come up in the audience we haven't been able to answer and put them together in 1 or 2 sheets that we can give to the Hosted Payload Alliance and give to our partners at Space News, and continue to explore these questions at length, because I think they really speak to a need for a coordinated effort, certainly within the government, commercial, and certainly with our European friends and partners in this business. Because we think, and the reason we put this on the agenda was that this is an opportunity for us. Why haven't we done it sooner? It's hard. And as we heard yesterday, we'll do the hard stuff as fast as we can. So thanks for joining in with us. Thanks for all our panelists for being part of this today. And thank you most of all for engaging in what we hope will be a culture-changing event for our access to space policy. Thank you very much.